Welcome to Docker Basics to Brilliance course. My name is Kastro Kiran. In the last 4 videos, we have understood how to write a Docker file by using the different keywords that are available, which are known as the Dockerfile keywords or the Dockerfile components. As a part of Docker Basics to Brilliance course, in this video, I am going to cover a mini project which is developed by using a particular type of application. If you remember, we were talking about the application architecture in the very starting videos of this particular course, where I was telling that for any application, we have three major components. The first component is a front-end component, the second component is back-end component, and the last component is the database component. There are different programming languages which will be used in order to develop the front-end component and also the back-end component. Coming to the backend component, we know that in order to develop the backend components of an application, we have to use the different programming languages such as Java and Python. Coming to the front-end component, there are different languages that will be used in order to develop the front end of an application such as HTML, CSS, React.js. Like this, we are going to use different things in order to develop the different components of an application. As a part of Docker Basics to Brilliance course, here we are going to see three mini projects where we are going to see how to Dockerize the applications which are developed by using a particular type of programming language. As a part of this video, where I'm going to discuss about mini project 1, where we are going to see how to Dockerize an application which is developed by using Python programming language. Before talking about how to Dockerize the Python-based application, we will understand the basic principles of Dockerizing an application, and then we will write the Docker file. Once we write the Docker file, we are going to build the Docker image, and then we are going to run the Docker container. Once after we run the Docker container, we are also going to access the application. This is the whole concept that we are going to discuss in this particular session. So first, let us understand the basic principles of working with Python. We know that Python is a programming language which is used to write the source code of the application. Python is a programming language which is used to write the source code of the application, Now, people will also call the Python as the general purpose scripting language. It is also called as Python is also called as scripting language. Okay, Python is also called as scripting language. So we can use Python in order to write the script for our applications. Now, all the Python-based applications will have the extension as .py. Okay, for all Python-based applications, the extension will be .py. Suppose, let's say you are writing the code for an application called Amazon Prime or Netflix, we can say Netflix. So for the source code of the Netflix application is developed by using Python code. Let's say Python is used in order to develop the Netflix application. So the source code file, which consists of Netflix related application or Netflix related details, will have the file name as netflix.py. So this is basically the extension of Python files. Just like for Java files, we have .java files. Similarly, for Python files, we have the extension as .py as the extension. One major advantage of working with Python is compilation is not required for the Python programs. Compilation is not required for Python programs. So the reason why compilation is not required for Python programs is Python is basically a scripting language. So whenever you are using Python in order to develop the application, you don't actually have to do the compilation process. Now, what is meant by compilation? Suppose if you understand the concept of the Java programming language, all the applications which are developed by using Java programming language will have the file extensions as .java files. All the applications which are developed by using Java programming language will have the file extension as .java. Now, if you want to run the application which is developed by using Java programming language, what you have to do is first you have to compile the project. Okay, first you have to compile the file. Now, what is meant by compilation? the conversion of the .java files into .class files is known as a compilation. Why do you want to compile the .java files into .class files? If you remember, in the .java files, the human understandable language will be available, but machine will not understand, or the computer will not understand whatever the things that are available in the .java files. So if you want the machine to understand your language, you need to compile it. That's called as a compilation. So the conversion of the human understandable language into machine understandable language is known as compilation. That is, conversion of .java files into .class files is known as a compilation. Since Python is a scripting language, compilation is not required for Python-based applications. Now, if you want to compile, we are going to use a build tool which is known as a Maven build tool. In the next video, we are going to see how to Dockerize Java-based applications. There we are going to discuss in detail about the compilation and the build tool which is known as a Maven as well. Right. Now, let us see how to write a Docker file for Python-based application. Now, in order to write a Docker file for the Python-based application, I hope you all have watched the previous 4 videos where I have talked about the different keywords that are required in order to write a Docker file. Now, let's see how to write a Docker file for Python-based application. So any Docker file should start with one keyword, which is known as from keyword. That's the basic thing. Any Docker file that you are writing, it should start from a keyword which is known as a from keyword. So why we are going to use a from keyword? If you want to get the base image for our application, we need to pull that base image by using the from keyword. So from space, let's say I am developing the application using Python programming language. So what base image I need? I need Python as the base image. Let's say Python colon 3.6 version of Python I need in order to work with the application. That's basically from Python colon 3.6. So here 3.6 represents the version of the Python programming language. Why I'm using Python here? Because we are going to Dockerize a Python-based application. So that's why I am trying to pull the Python as a base image by using the keyword which is known as a from keyword. And then I'm going to write another keyword which is known as a maintainer keyword. So we know that maintainer keyword is something which is used to represent the author name of the Docker file. Okay, who is maintaining the Docker file? Writing the maintainer keyword is completely optional. If you want, you can write. Even if you skip also, that doesn't make any difference to the Dockerizing of application. So these are the 2 keywords that I'm going to use. From represents pulling the base image from the Docker Hub. Maintainer represents who is the maintainer of the Docker file, or who is the author of the Docker file. Right. Now, let's say we want to copy the Python code from our local system to the container location. Okay, now I want to copy the Python code from our system to the container location. If you want to copy the code from the local system to the container, we know that we are going to use a keyword which is known as copy keyword. So why copy keyword is used? If you want to copy the code that is available in your local system into the container, we are going to use the copy keyword. Copy space dot space slash app. What does dot represents? We have already seen dot represents the current working directory. Okay, dot represents the current working directory. And slash app is the default location that will be there. Okay, slash app is the default location that will be there. So here what I am doing by using copy keyword, I want to copy the content that is available in the current working directory. Dot represents current working directory. I want to copy everything that is available in the current working directory into the slash app path. Okay, into the slash app path, which will be there inside the container by default. Okay, when you run the container, by default, this directory will be there, or slash app path will be available inside the container. By default, it will be available, right? So whatever the content that is available in the current working directory, I am copying that content to the slash app path, which will be available inside the container by default. We are not going to create this path. Okay, by default, in the container, it will be there, right? Now, let's say here what I am doing, I am copying the content from current location to this particular location. Now I want to switch to this particular location. So if you want to switch to this particular location, we know that we can use a keyword which is known as work dir. What is meant by work dir? If you want to switch to a particular location inside the container, then we are going to use the work dir keyword. Now, to which location I want to switch immediately when the container is run, I want to go inside the slash app path. Okay, I want to go inside the slash app path. Why I am going inside the slash app path? Because my application source code will be available inside this slash app path only. So that's the reason why I am using the work dir, where I am going to switch to this particular path. That's what work dir represents. Now we are going to use one more keyword which is known as expose keyword. If you remember, in the last video, I was talking about expose keyword. What does expose keyword represents? If you want to expose the application to a specific port number, then we are going to use the keyword which is known as expose keyword. By default, all the Python-based applications will run on port number 5000. So what I am doing here, I am exposing port number 5000 to the general public or to the end users. That's what I'm giving expose expose space 5000. Can you change this Python port number? Yes, you can change. Instead of 5000, you can give any number, whatever that is required, so that the application will run on this particular port number. In order to develop a web application using Python, we need to use certain kind of frameworks. For Java, we have certain kind of frameworks such as a Spring framework like that. Similarly, for Python-based applications also, that is, in order to develop the Python-based web applications, we are going to use a framework which is known as Python Flask. Okay, we are going to use a framework which is known as Python Flask. Now, here what we need to do is we need to install this Python Flask framework. Okay, we need to install Python Flask framework. Now, in order to install the Python Flask framework, what I will do is I will use the run keyword. Okay, I will use run keyword. Run space pip space install space -r and then requirements.txt. I'll explain you what is this one. So here what I am doing, we know that Python-based web applications will use a framework which is known as Python Flask framework. So by using run instruction, what I am doing, I am trying to install application, the framework, that is Python Flask framework. Now here you can see pip is available. What is a pip? Pip is nothing but the package manager that is available in the Python. Okay, pip is a package manager that will be available in the Python. If you remember, for Linux, we have the package manager as yum package manager. For Ubuntu, we have the apt package manager. Right. So we know that run instructions will get executed while creating the image. So here what I am telling is whatever software that I am going to include in the file called requirements.txt. This is the default file which we have to create. How will you create? By using run instructions. Now, let's say whenever you want the additional frameworks in order to deploy the application or in order to develop the application, we need some external dependencies or we need some external frameworks. All the frameworks, if you want to download, you are going to keep it in a file which is known as requirements.txt file. Okay, requirements.txt file. So here what I am telling is whatever the softwares that I am going to install or that I am going to mention in the requirements.txt file, all those softwares should get installed. Okay, all those softwares should get installed. That is why I am using run as the keyword. Okay, that is why I'm using run as the keyword. Now, if you want to run or if you want to execute the Python application, okay, now I want to execute the Python application or I want to run the Python application. So whenever you want to run or execute the Python application, we know that we have a keyword which is known as entry point keyword. Okay, which is known as entry point keyword. So what does entry point keyword represents? If you want to run an application, it need not be a Python application. It can be a Java application. It can be any type of application. So in order to run or execute the Python-based applications, I am going to use a keyword which is known as a run keyword. Now, inside the entry point keyword, what I am doing is I am giving Python. Why I am giving Python? Because my application is related to Python. Okay, my application is related to Python. So I'm giving Python here. Suppose if your application is related to Java, then you should give Java, right? And then comma space where your application source code is available. Let's say the application source code is available in a file called app.py file. Okay, the application source code is available inside a file which is known as app.py file. This is what the entry point instruction will talk. So app.py is my Python application file name. So this is the Docker file that is required in order to execute the Python based application. The same Dockerfile keyword I have also provided in the GitHub repository. So I'll provide you that GitHub repository even in the notes also. When you are working, you can clone that repository or you can fork that repository to your local GitHub account and then you can work it out. So this is the basic Docker file that I'm going to use in order to Dockerize the Python based application. Here, if you see, I don't have the source code inside the file called app.py file. So what I have is I already have one GitHub repository where the source code of the application is available and the same content, whichever I have written inside the Docker file, it is also available in the Docker repository. When you're working, you can clone the Docker repository to your GitHub account and then you can Dockerize the application. So let me show you the GitHub repository that I'm going to use in order to Dockerize the Python based application. So this is the GitHub repository that I'm going to use in order to Dockerize the Python based application. So this is the repository name docker-python-project. The same repository, I'm going to share it in the notes as well, so that you can also work it out when you are practicing. So I'll give the repository URL here, where I have my own Python-based application that is kept inside this particular repository. So here you can see inside this repository called docker-python-project, I have the Docker file, I have one README file, and I have the app.py file. So this is where my source code of the application will be available. And then I also have the requirements.txt file. So let's understand the importance of each one of these files. So Dockerfile, what will be there? The Dockerfile instructions will be available. If you click on Dockerfile, whatever I have explained so far, all those instructions I have provided here itself. You can see from Python 3.6 maintainer I have given, copy I have provided, and I am switching to /app path by using workdir command. And then we know that Python applications will run on port number 5000. That's by default. So I want to open the port number 5000. For that, I am using the expose keyword. And then for Python based applications, we need the package manager. So pip is the package manager for Python. So I am going to install the pip package manager by using the run keyword. Now here, whatever the frameworks that are required in order to Dockerize the applications, we are going to keep all those frameworks or additional softwares that are required inside a file which is known as requirements.txt file. And then I am going to run or execute the Python application by using the entry point keyword. In the entry point, since the application source code is developed by using Python programming language, I have written Python, and my source code of the application will be available inside the app.py file. So where this app.py file is available, it is available inside the repository. If you see here, there is a file that is called as app.py file. If you click on app.py file, you can see the source code of the application. So this is the source code of the application that I have written inside the app.py file. But anyway, do we need to bother about the source code of the application? No. So as a DevOps engineer, we don't have to bother about how to write the source code of the application. Developers will be available. They will be taking care of how to write the source code of the application. And then comes the next file, which is known as a requirements.txt file. So what will be there inside the requirements.txt file? Whatever the frameworks or whatever the additional softwares that are required to get downloaded, all those softwares I am going to mention in the requirements.txt file. If you open the requirements.txt file, I was telling that we have to download one Python Flask, which is a framework that is required to develop the application, that is Python based application. So I have mentioned Flask here, where I have mentioned Flask requirements.txt file. Now, for every project, when you are working in the real-time scenarios also, you will be having the Docker file, which is essential one. And you will also be having the application source code. If it is developed by using Python programming language, then app.py file will be there, or some other name will be there instead of app, but extension of the file will be .py. And you will also have the requirements.txt file, where developers are going to mention what kind of additional frameworks are required inside this requirements.txt file. Sometimes, as a DevOps engineer, we also have to write this requirements.txt file. If you ask me, which files are we going to write as a DevOps engineer? As a DevOps engineer, we have to bother about writing the Docker file and mentioning the softwares that are required inside the requirements.txt file. Readme.md file is an optional file which is not mandatory when you want to deploy the application. Now let's see how to Dockerize this particular application, which is available inside my GitHub repository. Now, firstly, what we will do is, let me go to the mobile system. If you see, let us verify whether Docker is up and running or not. So how will you verify whether Docker is up and running or not? We know the command which is known as sudo service docker status. If you click enter, you should see active and running. Currently, what is the status of Docker? It is inactive. So let us start the Docker. How will you start the Docker? Sudo service docker start. Okay, sudo service docker start. Click enter so that the Docker will get started. Once the Docker starts, let us verify whether Docker is running or not. How will you verify the status of the Docker? Sudo service docker status. You can see Docker is currently active and running. If you remember, on the very first day of my Docker practical sessions, I have installed or I have launched one instance. In the same instance, I am going to work with the deployment or the Dockerization of all the three applications that we are going to see as a part of mini project series, right? So now what I am doing, currently my Docker is up and running. So let me clear the screen. Can you check the Docker images that are available? Yes. So you can execute Docker images. You can see there are some Docker images that are available. If you want to see the list of running containers, we have this command docker ps. You can see there are no containers that are actually in the running state. If you want to see the list of all containers, then docker ps-a will give you the list of all containers. Now I want to delete all the unused images and also the unused containers. So how will you delete all the unused images and unused containers? Docker system prune-a. Okay, Docker system prune-a is the command to delete unused images and unused containers. Click enter. You can see, are you sure you want to continue? Just press Y, so that what will happen, it is going to remove all the stopped containers, networks, images which are not being used, and also the build cache. Yes, I want to delete everything. So let me clean my EC2 instance. So for that reason, I'm using Docker system prune-a. It will delete everything that is available. Now let's verify. You can see how much space has been freed down. It is 1.347 GB of space is cleaned. So let me clear the screen and let's verify whether we have any Docker images or not. You can see Docker images. There are no images that are available. Let's see the list of running containers. There are no containers. Let's see the list of total containers. You can see nothing is available. There are no Docker images. There are no running containers, and there are also no containers which are available in the stopped state as well. Right. Now what we will do, we are going to Dockerize the Python-based application. Okay, we are going to Dockerize the Python-based application. Now currently, where is my source code? My source code is available in the GitHub repository. Now, first thing what you have to do is you have to clone the source code. Okay, you have to clone the source code. So how will you clone the source code? Let me write the steps. Okay, I'm going to write the steps here. Now, the very first step that we need to write is clone the code to the virtual machine. So how will you clone the code? To clone the code, we have the command which is known as git clone. Okay, git clone space repository URL. So where is my source code? My source code is available in this repository. So git clone space the repository URL. But before cloning the source code, do I have Git in my EC2 instance? Let's verify. Git space -- version. You can see command not found. What does it mean? It means Git is not installed. Now, how will you install Git? So the first thing that you have to do is we have to install Git. Okay, install Git in the virtual machine. So how will you install the Git? In order to install the Git, we have the command sudo yum install git-y. This is the command that is used to install the Git software. So let me install the Git. Sudo yum install git-y. So you can see the Git is getting installed. Once the Git gets installed, then how will you verify whether Git is installed or not? Git space -- version. Click enter. You should see the Git version, right? So I have first installed the Git and then I have verified Git--- version. Okay, Git--- version. The next thing what we have to do is we have to clone the code. Where is the code? It is available in the GitHub repository. When you are practicing, what you can do is you can fork this particular repository. So you can see there is an option called fork here. So when you are practicing, you can fork this repository so that the repository will be copied to your GitHub account. Then you can give your own repository URL. Okay, right. So now how to clone the repository? We will use a command called git clone. So I'm just going to copy this entire one and I'm going to first clear the screen here. Let me clear the screen. Now let me clone the repository. Okay, just git clone space the repository URL. So just click enter so that the source code will get cloned into the virtual machine. Now, if you want to see whether the repository has got cloned or not, just give ls so that you can see Docker Python project. Can you see the same name here? Docker Python project. That means the application has got cloned, the source code of the application and all the things. That means the content, whatever is available in the GitHub repository, it is now cloned into this one. So now let me switch to this particular directory. So how will you switch to directory? CD space Docker space Python project. Okay, click enter. Now, if you do pwd, you can see currently I am in Docker Python project working directory. Right. Now, let us do ls so that we will be able to see the app.py file, the Docker file, readme.md file, and requirements.txt file. So we have already understood what is the importance of each one of these files as well. So I'm not going to talk much about these files again. So let's see what is the content that is available inside the Docker file. So if you want to see the content that is available inside a Docker file, we have a command which is known as a cat command, cat space Docker file. That is file name. Click enter. You can see I have the keyword, I have the Docker file instructions inside a file which is known as Dockerfile. Right. Now what we will do, we will Dockerize this application. Okay, we will Dockerize this application. Now, in order to Dockerize the application, the first thing that we have to do is we have to build the image. Okay, we have to build the image. So let me clear the screen first. Cat space Dockerfile. So you can see the content. Now we have to build the image. Now, how will you build the image? If you want to build the image, we have the command docker build. Okay, this is the command docker build -t. -t represents tag. Okay, -t represents tag. Space image name. You can give any image name here. I will give the image name as Python/app, Python-app. This is my image name. Here you can give any image name and then give dot. What does dot represent? Dot represents the current working directory. This particular command will look for the Docker file. Okay, it will look for the Docker file, and by using the Docker file, it will build the Docker image. Okay, by using the Docker file, it will build the Docker image. Where is my Docker file? It is there in this path. So that is the reason why I am giving dot here. Instead of dot, can you give the path also? Yes, you can give the path wherever the Docker file is available. Let's say I have executed pwd, right? So if you see pwd, in this path, the Docker file is available. So you can give the path also instead of dot here. That's anything up to you, right? So let me click enter so that the Docker image will get created. You can see the step-by-step execution of all the Docker file instructions. So what is the first step? The first step is to pull the image, which is a Python image, the base image from the Docker Hub registry. You can see the Python image is getting pulled. And then once after pulling, what is the next thing that it will do? It is going to run the Dockerfile instructions. That is work dir, the run, and then the entry point instructions. We will see how to do that. Before that, let me write the steps, whatever that we have done so far. So the first thing is I have installed the Git, then I have cloned the repository. Once after cloning the repository, change the directory. Okay, change the directory. So how will you change the directory? CD space the directory name. Whatever directory name that you have given, give that directory name. So what is my directory name? Docker-python-project. So you give that name so that you will be switching to that particular directory. Right. Once you switch to the directory, verify the contents. Okay, verify the content. So how will you verify the contents inside a directory? ls command. If you want to see the Docker file, so to see the content inside the Docker file, okay, to see the content available, let me write in this way. To see the content available inside the Docker file, we have cat space the Docker file name. Okay, cat space Docker file name. You can view whatever is your Docker file name, view the Docker file name. Currently, my Docker file name is Dockerfile. Okay, right. So, and then once you see the content, what you need to do, you need to build the Docker image. Okay, you need to build the Docker image. That's the next step. To build the Docker image. Okay, to build the Docker image. So if you want to build the Docker image, we have the command which is known as Docker build. Okay, Docker build -t. -t represents a tag space image name. Whatever name that you want, you can give that image name and then space dot. So what will happen? This dot will look for the Docker file in the current working directory. And then by using that Docker file, it is going to build the Docker image. So once the Docker image is built, how will you verify the Docker image? Okay, verify the Docker image creation. So how will you verify that? We have the command which is known as Docker image. So let's verify that. So you can see the Docker file has got built successfully. You can see this Docker file has got built successfully. This is the Docker file ID. Docker image ID. So let's verify Docker images. You should see the image, whatever we have given, Python-app. And this is the image ID. And when it got created, and you can see the size of the image. What is the tag? Latest is the tag, right? So now what we have to do is we have to work with running the container. Okay, we have to work with running the container. Now, before running the container, we need to understand the simple concept here. So as of now, okay, as of now, the image is available. Okay, the Docker image is available. That we know. Okay, the Docker image is available. Now, what we have to do, we have to run the Docker image. Okay, we have to run the Docker image. Now, whenever we are running, okay, whenever we are running the Docker image, okay, whenever we are running the Docker image, we need to specify, okay, we need to specify the port mapping. Okay, we need to specify the port mapping. This is very, very important. If you don't specify the port mapping, it is not possible to access the application. So currently the Docker image is available. Now I'm trying to run the Docker image. Once you run the Docker image, okay, whenever we are trying to run the Docker image, we need to specify the port number. Okay, we need to specify or we need to do the port mapping. So currently, what is meant by port mapping? Okay, what is meant by port mapping? This is a new concept again. So what is meant by port mapping? Suppose in my virtual machine or in my EC2 instance, I have created the Docker image. Okay, I have created the Docker image. This we know. I have currently created the Docker image. Now, what will happen when I run this image? Okay, when I run this image, what it will do? It will create the container. Okay, or container will get created. Container will get created. Container will get created. Once the container is created, okay, once the container is created, then we can access the application. But what is container here? Container is the runtime of a runtime environment, you can say runtime environment of our application. Runtime environment of our application. If you remember the containerization concept, I was talking that containerization will have the hardware components. On top of hardware components, we will have the host operating system. On top of host operating system, we are going to install the Docker engine that's called as container engine. On top of container engine, the containers will get created. And inside the containers, we can deploy the application and its related contents as well. Now, currently, where our application is running, our application will be available inside the container. Can we give the access to the containers for the end users? No, we cannot give the access, or the end users cannot access the containers directly. Okay, the end users cannot access the containers directly. They can only access the host operating system. So how will they access host operating system? By using the public IP of the instance. Okay, so currently our application is there inside the container. So the end users will not be able to access the application which is there inside the container. They can only access the host operating system. Okay, they can only access the host operating system. But in the host machine or in the host operating system, what is available? I have the Docker engine. Okay, I have the Docker engine. Using the Docker engine, what I have done, I have created the Docker image. Now, the end users cannot access the Docker container directly. Okay, they cannot access the Docker container directly. But if you want the application to be accessible, we need to give the access to Docker container. But in the real-time scenarios, we don't directly give the access to Docker container. Why? All the application-related information is available inside the Docker container. So the end users cannot access the Docker containers directly. In the host machine, what I have the Docker engine. Okay, I have the Docker engine, which is also called as container engine. Using Docker engine, I have created the Docker image. Okay, using Docker engine, I have created the Docker image. And then I have executed the Docker image. So in the host machine, okay, in the host machine, I have the container which is in the running state. Okay, what is there inside this container? Python application is there inside the container. Now, assume that container is running on one particular port number. Okay, assume that container is running on one particular port number. What is the port number? Let's call that port number as anything, something like 5000 port number. Okay, by default, the Python applications will run on port number 5000. So to access the container, what we have to do is we have to map the host machine. Okay, we have to map the host machine port number and the container port number. Okay, we have to map the host machine port number and container port number. This process is known as mapping. Okay, this process is known as mapping. So what is mapping? If you want to access the container, okay, which if you want to access the container where the application is running, we have to map the host machine with the container. Okay, we have to map the host machine with the container. This process is known as port mapping. Okay, this process is known as port mapping. So people should access the application from the host machine, but not from the container. Because whenever I recreate my container, okay, whenever I recreate my container, there is always a chance that the port number of the container will change. Okay, the port number of the container will change, but the IP address of the virtual machine, will it get changed? The public IP will get changed, but the private IP, will it get changed? No, it won't get changed. Till the time we are not terminating the instance, the private IP address of the host operating system, that is Linux instance, will not get changed. So since the private IP address of the host operating system will not get changed, we should always give the access to the host operating system, not to the container. Why we are not giving access to the container? Whenever we recreate, whenever, let's say I will kill this container and I will create a new container. So whenever we recreate the container, there is always a chance that this container port number will get removed. Okay, will get deleted. So for that reason, what we are doing is we are going to map the host port number with the container port number. Now, how to do this port mapping? In order to do the port mapping, first let us run the image. Okay, let us run the image. Currently, we have the Docker image. So let's run the Docker image. So to run the Docker image, okay, to run the Docker image, I'm going to do the port mapping here itself. Okay, to run the Docker image and to do the port mapping. Okay, and to do the port mapping, I am going to use one command here. As you understand this command very carefully, Docker run. Docker run is used to run the Docker image. Now what you have to do, -d -p. I'll explain what is this -d and -p, and then host port number. Okay, host port number colon the container port number. Okay, host port number colon container port number, and then give image name. This is the syntax of how to run the Docker image and how to do the port mapping. So Docker run -d. So here -d represents, okay, let me write that, -d represents the detached mode. -d represents the detached mode. What is this detached mode? Detached mode means whenever you run this command without -d, what will happen is the commands will keep on executing. I'll show you that in some time. And then -p. Okay, the next one is -p. -p represents, okay, -p represents port mapping. Okay, -p represents port mapping. And here container port number, you can see container port number is nothing but the port number of the container. Okay, the port number of the container. Now let me give this particular one. So Docker run, okay, I'm going to execute this command in this way. Docker run -d -p host port number. Let's say I'll give the host port number as 5000. By default, Python will run on which port number? 5000 port number. So the first one represents host port number and the second one represents the container port number. Can you change the host port number? Yes, you can change. You can always change the host port number. Right. Now let's give the image name. What is my image name? Let me verify what is my image name. Python-app. Okay, Python-app. So Python-app. This is my image name. Now, once you do this, what will happen? The Docker image will run and also the port mapping will happen. Remember, this one is host port number, that is left side one is host port number, right side one is container port number. Okay, left side one is host port number and right side one is container port number. Right. Now, what we have to do, we have to run the Docker image. So how will you run the Docker image? Docker run currently I will not give -d. Let me give -p alone. Let's see what will be the difference that happens. And then host port number, that is 5000, and container port number, that is again 5000, and then the image name. What is my image name? Python-app. Okay, Python-app. Let me click enter. You can see the image is getting built. So here, if you see the container, whatever we have created, it is not running in the detached mode. Why I am telling it is not running in the detached mode? Can you see the line to execute the next command? No, you cannot see anything that in order to execute. Currently, I am typing something in the keyboard, but still I am not able to get it. What is the reason for that? The reason is the container is not running in the detached mode. So how will you run a container in the detached mode? You should give Docker run -d instead of -p alone. -d also you should give. Then it will allow us to execute the rest of the commands as well. Let's see that. So how will you come out of this? If you want to come out of this, you can see press Ctrl+C to quit. Let me do that. Ctrl+C. You can see I have quit. Now I can execute the commands. So currently what I'll do is, let me clear the screen. Now I will write the command Docker run -d, that is in detached mode, and then -p. Okay, Docker run -d -p, and then host port number, which I am mapping to the container port number, and image name. What is my image name? Python-app. I think that's the exact image name. Let me verify correctly. Yeah, Python-app. Now let me click enter. You can see it is now showing me to execute the next command. That's the importance of giving -d. If you don't give -d, it will not allow us to execute the next commands. That is what we have seen. And then I have pressed Ctrl+C. Then it has shown me to execute the next command. So since I have given -d here, it is directly allowing me to execute the rest of the commands. Now, can I see the container that got created? Yes. How will you see? Docker ps. If you execute, you can see there is a container that got created. By using which image it got created? Python-app. When it got created? 29 seconds ago, it got created. What is the status? It is up and running. Okay, you can see the container port mapping also. 5000 is the host port number, 5000 is the container port number. Now I want to access the application. So how will you access the application? If you want to access the application, okay, so let's access the application. How will you access the application? In order to access the application, you should give the public IP address of the instance. Okay, public IP of the instance, that is virtual machine, and then : the port number. What is the port number that is running Python application? 5000 and then slash you give, that will show you the application. Let's see that. But currently, have I enabled the 5000 port number for my EC2 instance? No. So let us verify that. You can see, you select the instance, go to security. In the security, if you see if you click on this particular link under security groups, you will be able to see whether 5000 port number is allowed or not. You can see the 5000 port number is not allowed, only 22 port number is allowed. So let me enable the port number 5000. So how will you enable port number 5000? Click on edit inbound rules, add rule, type is custom TCP, and then port range is 5000 and source is anywhere. So when I give anywhere, what will happen? Anybody across the globe, they can access my application. So let me click on save rules so that the port member has got enabled. Okay, so that the port number has got enabled. Now what you have to do, copy the public IP address of the instance. Okay, copy the public IP address of the instance and then go to new tab. In the new tab, paste the IP address colon where my application is running 5000 port number. Okay, 5000 port number and then slash. So click enter so that you should be able to see the Python application. Let me click enter. You can see this is my Python based application. How this code is coming? It is coming because I have written that code in the app.py file. So if you click on this particular link, you will be able to see the Docker playlist, that is a Docker Basics to Beginners course playlist. And if you click on this particular link that is there, you can also directly connect me on LinkedIn as well. So this is the content that I have written inside the app.py file. So like this, you can also access the inbuilt links which I have provided here as well. So if you want, you can look into the rest of the videos, whatever I have created so far in the class of Docker Basics to Beginners course. And you can also connect me on LinkedIn by clicking this particular link so that we can stay connected on LinkedIn as well. So this is how you can Dockerize the Python based application. So I hope this particular session is helpful for you in order to Dockerize the Python based application. This is completely a real-time concept where we are going to know how to Dockerize the different types of application. This is all about this particular video. In the next video, we are going to see how to Dockerize the Java-based applications as a part of mini project 2. Thank you.